Good morning, everyone. Today is October 16th, and we will be doing Unit 2, Lesson 4. So let's start. So today's lesson is all about solving polynomial equations. In this section, we'll learn methods of solving polynomial equations with a degree higher than 2 by factoring using the factor theorem. We'll also identify connections between the roots of polynomial equations, the x-intercepts of the graph of a polynomial function, and the zeros of the function. Alright, so we're going to use technology to graph, let's say this right here, x to the power 4 minus 13x squared plus 36. And we have a graph over here, and we can clearly see that there are 1, 2, 3, 4 x-intercepts here. There are 2 local minimums and a local maximum, and that local maximum just happens to be the y-intercept as well. So determine the x-intercepts from the graph. So we know negative 3 and 0, negative 2 and 0, 2 and 0, and 3 and 0 are the x-intercepts. Pretty straightforward. And we're going to use now factors to determine the roots. So how can we do that? Well, one way of factoring an equation when you have exponents that are 4 and 2 is to kind of treat it like a quadratic. And I'll show you what I mean by that. Okay. So let's say our equation is this. And I'm going to write a let statement. Let W, doesn't really matter which letter you choose, let W equal x to the power of 2, x squared. So I'm going to rewrite this equation in terms of W now. So this is going to be not x to the power of 4, but W to the power of 2. And why is it W to the power of 2? Well, x squared is x to the power of 4, right? And since this is x to the power of 4, well, this is just w squared because x squared is w, so this is just w squared is equal to x to the power of 4. So I'm just substituting a variable. This middle part becomes 13w. Why? Because x squared is w, so any time you see an x squared, just replace it with a w. We have plus 36. Now remember, this is usually only done for when you have an example where you have even exponents and it's like 4 and 2. Makes your life a bit easier. Now this is essentially a quadratic. Since this is a quadratic, we could just use our rules for solving quadratics. We know that we can add 2 numbers, and if they're equal to the middle term, and we can multiply the same 2 numbers, and they should equal to 36 in this case. Now, what are 2 numbers that, make this true? I think 3 and 12. Okay, no, let's just write all the variables out. Let's see if this even works. Okay, so for 36, we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't go, 6 and 6, and once you get to the halfway point, 6 and 6, numbers are technically repeating, so we can stop there. So these are all the factors of 36, and okay, it's actually going to be 4 and 9. Hopefully you guys can see that. So negative 4 and negative 9, when added together, give me negative 13, and negative 4 and negative 9 when multiplied together give me positive 36. So we can split the middle term now, and this is now a grade 10 problem. Common factor between the 2, common factor between the last 2. We always try to factor out the negative term from the first term of the second group. So now we have w times w minus 4, and minus 9 here, and we have w minus 4. If you did it correctly, the brackets should be exactly the same, and that is the case here. And there we go. So we factored it. We factored the initial equation. The only thing now is to rewrite the initial equation back in its original variable. So we now resubstitute x squared. So wherever we see a w now, write x squared. So we have x squared minus 9 and x squared minus 4. Question is, can we factor this further? And if you remember from grade 10 and from grade 11, that when you have two values and there's a minus sign, you're kind of taking the difference. And you should always think of difference of squares whenever you're in a situation like this. Hopefully everyone can see that this becomes x plus 3. Oops. And x minus 3. And this bracket becomes x plus 2 and x minus 2. Oops. So both of these brackets can be factored further into these four brackets now, and that's it. We have factored fully. We can't factor anything more than this. And this shows us that we have 4 x-intercepts or 4 zeros, which is true. And this is the notes. You can see they did the exact same thing. How are the x-intercepts in the graph related to the roots? The zeros of the equation are the x-intercepts. Yeah, that's something I think we've mentioned a few times. So when it comes to stating solutions to the following polynomials, what does that mean? Essentially, we're just solving for what value of x will make the equation equal to 0, because we have an equation equal to 0, right? So what will make this equal to 0? Well, I know when I have my equation in factored form, anything multiplied by 0 will make the whole thing 0. And since these three things are just multiplying with one another, you can separately make mini equations, make them all equal to 0, and solve using that method. So x equals 0, there's really nothing to do there. It's already solved. X is equal to 0. 2x plus 3 equals 0. Well, bring the 3 over, that becomes negative 3. X is equal to negative 3 over 2. And bring the 5 over, x is equal to positive 5. So my 3 zeros in this example, or my solutions, are x equals 0, x equals negative 3 over 2, and x equals 5. Pretty straightforward. Nothing too complicated, nothing too difficult. Same thing here. We have two numbers that are being multiplied to one another. So if any one of them is equal to 0, we know the whole thing is 0. So 2x squared minus 3, I take the first bracket, I make it equal to 0. Then I do 2x squared is equal to positive 3. Then x squared is equal to 3 over 2. At this point, I have a square on one side, so I can just take the square root. And here, don't forget that there is always a positive answer and a negative answer. So there's two solutions here. Positive root 3 over 2. Sorry, positive square root of 3 over 2, and then the negative root of 3 over 2. Same thing we do now with the second bracket there. 3x squared plus 1 is equal to 0. 3x squared is equal to negative 1. X squared is equal to negative 1 over 3. And then the square root of negative 1 over 3. Now question, can we take the square root of a negative number? We cannot. You cannot take the square root of a negative number. So there are no real solutions for this second bracket here. So the only zeros and the only solutions are from the first bracket. So this equation only has 2 zeros, only 2 solutions. And here we go. And we're not going to talk about real and imaginary numbers in this course. So the answer is just x1 and x2, that's it. Methods of factoring. So we've learned long division. We've learned synthetic division. we know factor by grouping, that's from grade 10. Difference of squares, also from grade 10, and also reinforcing grade 11. Common factoring, I think that was probably introduced in grade 9. Trinomial factoring, once again in grade 10, and sum and difference of cubes. That's something that's new to this course. So here we have an example of factoring something that's in the form a cubed plus b cubed, or factoring something that's in the form a cubed minus b cubed. And we're gonna go into some examples from those. Let's do some basic factoring and then solving. So we know that here we can factor the value of x. So always try to do common factoring if you can. So this just becomes x squared minus x minus 2 is equal to 0. And we see if we can factor this bracket further. This looks like a quadratic, so I think we can. Any two values that add up to -1 and the same two values that will then give us a product of -2. And let's see, I'm thinking 1 and -2 and 1 and -2 solves this. So here x minus 1, x minus 2 equals 0. Wait, did I do this right? No, doesn't look right. Wait, what? Hold on. Where did I make a mistake? No, that's right. And then two values are, what's 1 times -2? -2, 1 plus -2, -1. No, that's right, -1, -2. Hold on. What did I do wrong? X squared minus, let's do minus. Wait, you know what? Let's take a look at the solutions. X minus x plus 1. No, I understand that, but why don't I have plus 1? Oh my gosh. I don't know why I did that. Sorry. X. This is a positive 1. There you go. And I was like, oh my gosh, where am I freaking out? I got confused by looking at this -1. Sorry, small mistake. Okay. There you go. So yes, so plus 1 and -2. There you go. That's equal to 0. And then our solutions are obviously x equals 0, x is equal to -1, and x is equal to +2. These are my solutions and my zeros. Okay, let's move on to this one. In this example, so whenever you have 4 terms, I would recommend common factoring and then factor by grouping. So look for something common between the first pair and then the second pair. So let's see, the first two we can take out an x squared. And for these two, we can take out a -4. So this becomes x squared times 3x plus 1. This becomes -4. And -12 divided by -4 is 3. Then we get that x, and that's going to be plus 1. If you did it right, the brackets should be exactly the same. So we have x squared minus 4 in brackets and 3x plus 1 in brackets equals 0. And hopefully everyone can see that x squared minus 4 is just a difference of squares. So that's just x plus 2, x minus 2, 3x plus 1 is equal to 0. And now we can solve this. X is equal to 2, x is equal to -2, and then x is equal to that. Bring the 1 over, -1 over 3. So these are my zeros or my solutions to that.